Good morning to all. This is Khalandar Basha working as Associate Professor in the Department of ECE, Institute of Aeronautical Engineering. Today, I am going to present the Programmable Peripheral Interface, which is 8255. These slides are prepared by referring the textbook titled Advanced Microprocessor and Peripherals, authors A.K. Ray and Gurchandi, the publication Tata McGrath. The 8255 is a general purpose programmable I/O device designed to interface CPU with its outside world such as ADC, DAC, keyboard, stepper motor, etc. As 8086 processor is not having any ports for connecting or interfacing an I/O device, we are going to use a interface media, that is 8255, between a I/O device and microprocessor for communicating with the I/O device. This PIO or PPI, Programmable Peripheral Interface, or Programmable Input Output, which is 8255, will act as interface between the processor and the I/O devices. The 8255 can be programmed according to the given condition. It consists of 3 8-bit bidirectional I/O ports, that is port A, port B and port C. The ports can assign as input ports or output ports. So they will functionate as input or output function. To program the function to all the 3 I/O ports, it contains a register to be programmed called as control register. This control register we can configure in the 2 modes. One is bit set or reset mode, that we will call as BSR mode. The second one is I/O mode, input I/O mode, which we can configure the ports A, B, C depending upon the mode of selection. We can configure them in the input or output port. The control register defines the function of each I/O port and in which mode they should operate. The main features of 8255 are: it is a programmable parallel I/O device. It contains a total 24 programmable I/O pins arranged as 2 8-bit ports, that is port A and port B, and 2 4-bit ports, that is port C upper and port C lower. These 2 4-bit ports, that is port C upper as well as port C lower, we can configure as a 8-bit port also, that we can refer as port C. It has 3 8-bit ports. They are port A, port B and port C, which are arranged into 2 groups of 12 pin each. So these 3 ports are categorized into group A and group B. Under group A, the port A and port C upper are present, which is port A, in which port A is 8-bit size, port C upper is 4-bit size, total 12 pins. Whereas under group B, we have port B and port C lower, which by combining these 2 ports, we can use for 12-bit I/O data transmission. This 8255 is fully compatible with Intel microprocessor families, and it is TTL compatibility, where TTL stands for transistor logic. Direct bit set or reset capability is available for port C. This 8255 in I/O operations we can use in 3 modes. They are mode 0, which we can call as simple I/O mode; mode 1, strobed I/O; mode 2, strobed bidirectional I/O. We will see in detail description of these three modes of operation to be used for configuring the ports in the input output. The block diagram of 8255 is shown in the figure, which is consist of a data bus buffer and a read-write control logic, Group A control block, Group B control block, Group A port A, Group A port C upper block, Group B port C lower block, Group B port B block. Here, this will act as, this is the internal data bus of 8255. Whatever I am showing in the red color, it is the internal data bus of 8255 through which we can have the data transfer between one block to another block. Now we will see the description of each and every block. The block diagram of 8255 PPI contains the following blocks: data bus buffer, read-write control logic, Group A and Group B control, port A, port B and port C. First we will see the data bus buffer. The 8-bit bidirectional tri-state data bus buffer is used to interface the 8255 internal data bus with the system data bus, that is 8086 processor or any processor system bus. The direction of data bus buffer is decided by a read-write control signal generated by the processor. When read is activated, it transmits data to the system bus. When write is activated, it receives the data from the system bus. Control words and status information is also transferred using the data bus. The next block is a read-write control logic. This block accepts inputs from the system control bus and address bus and performs various operations. The control signals are a read bar and a write bar, and the address signals used are A0 and A1. Along with, to enable 8255, we have chip select pin. The read signal, whenever this signal is equivalent to 0, it indicates the processor is reading the data from 8255. That is nothing but reading a IO port. When write bar is active, that is if write bar is equivalent to 0, the processor is writing some data to 8255. Either it may be a control word registered data or the data may be writing to the ports. Next, A0, A1, these two signals are used for addressing port A, port B, port C as well as control word register. When A1, A0 is 00, the 8086 processor accessing port A, 01 for port B, 10 for port C, 11 for control word register. To activate the 8255 for IO operation, we have to enable 8255 chip select, that is CS bar, we have to ground. The signals read bar and write bar are connected to IO read, IO write, or memory read or memory write. The chip select is connected to address chip select decoder. To enable it, we have to give some address information, whatever the address is assigned for 8255. The 8255 is enabled or disabled by the chip select line. When CS bar is equivalent to 0, 8255 will be enabled. When CS bar is equivalent to 1, the 8255 is disabled. The next block is Group A and Group B control. The 8255 IO ports are divided into two sections. That is, Group A will refer as GA and Group B, which will refer as Group GB. The Group A consists of port A and port C upper, whereas the Group B consists of port B and port C lower. The GA and GB control block receives commands from a read-write control logic to accept bit pattern from CPU. The Group A control will control the Group A ports, and Group B control block will controls the ports related to Group B for configuring either in the input mode or output mode. The bit pattern given by CPU consists of information, the control of operation of Group A and Group B, the mode in which they should be operated. We will say what are the various modes in detail later. Next, the port A and port B. These two are 8-bit ports. Port A and port B consist of 8-bit bidirectional data bus. So we can use as input port or output port by programming. It latch or buffer the 8-bit data input buffer. The functions of port A and port B is decided by the control bit pattern available in Group A and Group B control. The function of port A and port B are used as independent mode of operation. That means port A we can configure in one mode. Port B either we can configure in the same mode or we can go for other mode. Port C. The port C consists of 8-bit bidirectional data output latch or buffer and an 8-bit data input buffer. It is divided into two sections, that is port C upper, which will refer as PCU, and port C lower, which is PCI. These two sections can be programmed and used separately as a 4-bit IO port. That is, port C upper as one 4-bit port, port C lower as one 4-bit port. It can be used in the following modes: simple IO, handshake signals, and status signals. Handshake signals and status signals, it is used in coordination with port A and port B. Next, we will say the 8255 Programmable Peripheral Interface Operating Modes. The 8255 provided one control word register. It is selected when A0 and A1 are 1 and the chip select is active and write bar is also equal to a 0. For control word register, the read permission is not allowed. Only the processor or system can write the data to control word register. The bit pattern loaded in control word register specify an input-output function for each port and the mode of operation in which the ports are to be used. There are two different control word formats which specify two basic modes, that is BSR mode, bit set or reset mode, and IO mode. The two basic modes are selected by programming the MSB bit, that is D7th bit of control word register. If the bit D7 is equivalent to 1, then 8255 can be used in IO mode for IO operations. When D7 bit is configured or programmed as 0, then 8255 can be used in bit set or reset mode, which we can use for set or reset a particular bit of port C. First, we will see the BSR mode, where BSR stands for bit set or reset mode. The BSR mode is a port C bit select or reset mode. Only we can change or we can set or reset the ports, 4 bits of port C. The individual bit of port C can be set or reset by writing the control word in the control word register. The control word register format for BSR mode is shown in the given figure. Here, for configuring 8255 in BSR mode, we have to make MSB bit is equivalent to 0, indicating the 8255 is in BSR mode. The LSB bit D0, it is used for indicating either you want to set or reset the specified bit. If you write D0 bit as 0, the bits which we are specifying on the lines D1, D2, D3 will be reset. If it is 1, then the bits placed in D1, D2, D3 positions are used for set. The bits D1, D2, D3 are used for selecting a particular bit of port C. Whenever these three bits are 0, 0, 0, bit 0 of port C will be selected for set or reset. 0, 0, 1 port C1, 0, 1, 0 port C2, 0, 1, 1 port C3, 1, 0, 0 port C4, 1, 0, 1 port C5, 1, 1, 0 port C6, 1, 1, 1 port C7. Whatever the bit which we are configuring D1, D2, D3, based upon D0 signal, that particular port bit of port C will be set or reset. The next three bits, that is D4, D5, D6, they are don't cares. Either we can write 0 or 1 for each and every bit. It is not going, these three bits are not going to signify anything related to port C. The next 8255 we can use in IO mode. There are three IO modes of operation. Mode 0, which is basic IO mode. Mode 1, strobed IO mode. Mode 2, bidirectional IO. IO modes are programmed using a control word register. For configuring 8255 in IO mode, we have to write MSB bit, that is D7 should be equivalent to 1. The control word register for IO mode operation is shown in the figure. The D7 bit by configuring 1 indicates it is IO mode of operation. The LSB bit, it is for configuring the port C lower either in the input port or output port. The D1 bit is used for programming to configure the port bit as input port or output port. The D2 bit, it is used for the mode of operation for group B, that is port B and port C, whether we can configure in mode 0 or mode 1. When you write the D2 bit as 0, the group B ports are used in mode 0, that is basic IO mode operation. When we configure the D2 bit as 1, the 8255 group B ports will be used in mode 1, that is strobed IO. The next D3 bit, it is used for configuring the port C upper. By writing D4, either we can write the port C upper can be configured in the input port or output port. The D4 bit, it is for configuring port A either as input port or output port. The next two bits, D5, D6 will decide what is the mode of operation for group A, that is port A and port C upper. If we configure D5, D6 as 0, 0, the group A ports are in mode 0, that is basic IO. If they are configured as 0, 1, if you have configured this one as 0, 1, that means the group B ports are in mode 1, that is strobed IO, the strobed IO. Whereas if you configure these two bits as 1, 0, then the group A ports are configured in mode 2, that is bidirectional strobed IO. For the ports, port C upper or port B or port C lower or port A, to configure in input port, we have to write the corresponding bit as 1. If you want to configure a particular port in IO, that is output operations, then we have to configure that particular port bit as 0. This mode is selected by writing or programming the MSB bit, that is D7, the bit of control word register as 1. This mode has again three different modes of operations. That is mode 0, we'll call as simple or basic IO mode. Mode 1, handshake or strobe IO mode. Mode 2, bidirectional strobe IO. We will see what are these various modes of operation, how we have to configure each ports, what are the data information, which port will be used for control information, which port will be used, we will see in detail. First one is mode 0, we'll call as a simple or basic IO mode. It is a normal mode of data transfer. All the three ports are available for data transfer, that is port A, port B, port C. We can configure either in the input port or output port. In this mode, all the ports, that is A, B, C, can be used as input or output mode. The outputs are latched, but inputs are not latched. So before sending the data to the output ports, first it will be latched. From the latched output, it will be sent to the corresponding port. This mode has interrupt handling capability. It is less reliable because of not having any handshake signal. If the processor and IO devices are of same speed, the basic IO mode we can prefer, because the synchronous between IO devices and processor is there. If there are any slow response device, in mode 1, we can't interface IO devices with 8086 because absence of handshake signals. In mode 1, handshake signals are strobed IO. In this mode, the data transfer is done by using or configuring two ports, that is port A and port B. In this mode, the port A and port B can be used as input or output port. The port C are used for handshake signals. In this mode, the inputs and outputs are latched. This mode also has the interrupt handling capability and the signal control to match the speed of CPU and IO devices because of handshake signals. Handshake signals are nothing but before sending the data, it will give a signal indicating the data is going to be arrived. After receiving the data, the readiness of the other device, it will give a acknowledgement indicating the data is received. We will see in detail about the various handshake signals are present when we are configuring for input as well as for output. Mode 1 is a unidirectional handshaking, which means either handshaking can be done for input devices or output devices only. Input device, it will gives a strobe signal, that is STB, which is an active low signal, to 8255 before sending the data. If 8255 already have some data, then this request will not be allowed. Otherwise, the strobe signal will be considered for reading the data. Once the data is received, it will be sent to the processor. 8255 accepts data and stored it in the input buffer. As soon as it receives the signal given by IBF, that is input buffer full, if IBF is 1, it does not allow any another data to enter into 8255 PPA. Now 8255 has data that should be sent to 8086. It makes INTR high, indicating there is an interrupt request from the IO device to the 8086 microprocessor. Then the processor sends the read signal and makes the data transferred via data bus. As the read signal is given, immediately the interrupt signal will be deactivated. Now here, the various handshake signals we are using is strobe signal, which will give IO device to the 8255. Once the data is placed into the ports, then IBF will be generated, indicating the buffer is full. Once the data is captured into 8255, it will generate a interrupt signal for the 8086 processor. Then the processor will generate the read signal. Upon receiving read signal, the data which is captured by 8255 will be placed on data bus. Mode 1 for output handshaking. In this type, 8255 will be accepting a data from 8086. 8255 sends an interrupt whenever it is ready to accept the data from the processor. Then 8086 will send a write signal. As 8255 receives the data, it resets the output buffer full, because output buffer full is a active low signal. Then the output device acknowledges the received input on the line ACK. So when the processor wants to send the data or for transmission of the data to IO port, output port, first 8255 will send the data to 8255. Once the data is loaded into 8255, it will generate output buffer full. Upon generating output buffer full, the IO device can read the data from the ports. In mode 1, we know that port A and port B used for IOs. Once the data is captured by IO device, it will send an acknowledgement to 8255 indicating the data transaction, that is write operation to a IO device is completed. The last mode of operation for 8255, which is mode 2, which is bidirectional handshaking. In this mode, only port A is used for IO operations, whereas port B, that we can configure in mode 0 and mode 1. The port C is used for handshake signals. In this mode, the inputs and outputs are latched. The 5-bit control port of port C, that is PC3 and PC5, are used for generating or accepting handshake signal for data transfer on port A. The various handshake signals which we are having is OBF, that is output buffer full, acknowledgement, ACK, and there is an interrupt request which is used for both input as well as IO operation. PC4 is connected to strobe signal. PC5 is connected to IBF, input buffer full. The rest of the pins, that is port C0 and port C2, till that one, we are not having any significance. So we can use this one in IO operations. When the processor wants to read the data, first IO device will send a signal, STB signal, strobe. Once the strobe signal is generated, then the data will be placed on port A. Once it is loaded into the input latches, it will generate a input buffer pool. Upon generating input buffer pool, interrupt will be generated to the processor. Once the interrupt is generated, if the processor wants to read the data from the IO device, it will generate the read control signal. When the processor wants to send some data to output device, that is output port, then first the 8255 will give a interrupt signal to the processor indicating 8255 is ready for output operation. Then the processor will generate the write operation. Then the data will be loaded into port A latch. Once the data is loaded into port A latches, it will generate a control signal, that is output buffer full, to the IO device. Upon receiving this output buffer full, the data will be captured by IO devices through port A. After receiving the entire data by IO device, it will send an acknowledgement to 8255 indicating the data is received by the output device. So this mode 1 and mode 2 will be used for slow response devices. As the speed is not matching, we are using few handshake signals. Now we will see the comparison of various modes of operation, how the ports will be used, for what purpose the ports will be used. In mode 0, that is simple or basic IO mode, the port A, port B, port C upper, port C lower will work for as IO ports. In mode 1, that is strobed IO or handshaking signals. In this, port A and port B are used as IO ports, whereas port C upper is used for handshake signals for port A, port C upper. Port C lower, it will be used for generating handshake signals for port B. Whereas mode 2 operation is a bidirectional strobed or handshaking IO. In this, the data will be transferred to the IO device through port A, whereas port B we can configure either in the mode 0 or mode 1. The port C lower and port C upper are used for handshaking signal. Port C lower is used for handshake signals for port B, whereas port C upper will be used for generating handshake signals in port A. So with this, I conclude. Today we have discussed the 8255, which will call as PPI, which is Programmable Peripheral Interface, or PIO, Programmable Input Output Device. This is for interfacing a IO device with 8086 processor. We studied what are the various features of 8255. Then what are the various modes of operation, that is BSR mode and IO mode. How to configure our programmable 8255 for using in BSR mode and control word IO operation we have discussed by programming control word register. Then the various modes of operation in IO operations, that is mode 0, basic or simple IO operations. Mode 1, strobed IO operation. Mode 2, bidirectional strobed IO operations. Thank you all.
Like, share and subscribe. Hit the bell icon for more updates.